All right, good evening, everyone. So I guess some of the participants are still running late. We can get started now. I guess they will catch up as they when they join in. So pretty much we covered the two sample t-test yesterday, and we covered the one-way ANOVA test. So the few more tests which is there that we will be covering up in the analyze phase. And in the meantime, just wanted to kind of recap on this one. Say, when if you remember, we talked about the ANOVA test. When we have more than two groups, we use ANOVA. But if in case the data is non-random, we talked about that that we will be using a Kruskal-Wallis test. So wherever you used ANOVA, instead of ANOVA, you have to use Kruskal-Wallis test if your data is non-random. And how do we get to know about random or non-random? We run the run chart test, which helps us understand if the data is random or non-random. So in case your data is non-random, so instead of ANOVA, you will be using Kruskal-Wallis. So I'll just copy paste the same data just to kind of show you how we do this test. So because my data is random for more than two groups, so wherever they are more than two groups, I will be using one-way ANOVA. Like in this case also, we have this data, say ticket handler. I wanted to understand whether ticket handler is a root cause or not, whether ticket handlers will impact your ticket closure time or not. So I will be using ANOVA for this because there are more than two groups here. There are more than like there's data for Jaya, Nitin, Ravi, and Vandana. So two plus groups are there. And my data Y is random because we already checked the run chart. This data is random. What if this data would have been non-random? Then instead of ANOVA for this, we would have used Kruskal-Wallis test. So let's have a look at how we do the Kruskal-Wallis test. You go to stat, we go to non-parametric, and in the list of non-parametric, we have Kruskal-Wallis. So stat, non-parametric, Kruskal-Wallis. Response will be my business problem or the Y, which is ticket closure time, and the factor is your X. So you will be using this test only when your Y is non-random. So we select this and we check it out. Let's whether see whether this data is there a root cause or not. Looking at p-value, is this a root cause? Anyone? Is there a statistical relationship or not? Is it null or alternate? Anyone?
Alternate.
Absolutely, yes. Alternate. It is less than 0.05. Yes, we have enough statistical evidence which confirms that there is a relationship, there is an impact of the ticket handler on the ticket closure time. Here, look at this. It says null. All medians are equal. It's comparing the medians of the data. Why? Because the data was non-random. So instead of that, we are using this Kruskal-Wallis test instead of ANOVA, which will be comparing the medians of that. When we use ANOVA, it looks at averages, it looks at means of the data. Here, it is comparing the medians. So it's saying all medians are equal. Alternate will say no, at least one of them is significantly different. It's different. P-value confirms yes. There is a huge difference in their median. We look at this data also. Jaya's median, Nitin's median, Ravi's median, Vandana's median. There's a huge difference between Vandana and Nitin. So pretty much this is going to be used only in case when you are dealing with a problem like Y, which is non-random. Let's take up another X and see whether, say, qualification wise, we want to see whether it's a graduate, undergraduate, postgraduate, which is two plus group. There are more than two groups. If I have to do this test, so stats non-parametric Kruskal-Wallis, that's my Y, and my X is, say, user qualification. Now, can you help me understand, is there a relation or not? Is it null or alternate? Any any answers here? Is it null or alternate?
Yes, sir. Relation.
Is there is a relation?
Right, sir.
Okay. Is it null or alternate? 0.355.
So this is alternate.
Okay.
So this is null.
It is null. It is null. Why? Because it's, see, null alternate is when it's less than 0.05. When it's less than 0.05, this is bigger. This is null. So hence uh, we do not have evidence to prove this claim that qualification impacts the ticket closure time. We probably had this in the mind that graduate, postgraduate, undergraduate, whatever may be the qualification level, that may be significantly impacting the ticket closure time. Unfortunately, we do not have evidence to prove that. So we'll continue with the basic logic that be it graduate, postgraduate, or undergraduate, your performance level in terms of ticket closure time is going to be same. Is this okay with everyone? Uh, Kruskal-Wallis, everyone? Uh, would request you to please confirm. Is in case we are okay with it, we shall move to the next one. Is it clear to everyone, the Kruskal-Wallis?
Yes, sir.
Okay, perfect. Now, the only thing where we coming to is the next thing is the correlation test. The correlation test is something which we uh, will give you something extra. So we know what is p-value. We already understand that. But correlation test gives you extra information. So that's why we would probably need to understand it in little more detail. So p this gives you p-value with, like, either test also gives you p-value. This also gives you p-value. What does p-value tell you? It tells you whether there is a relation between x and y or not. That's what it tells you. But other than p-value, when you do a correlation test, it gives you an R value, which is known as Pearson's correlation coefficient. Now, what does this R value tells you? It tells you two things. In case of Pearson correlation coefficient, first thing, it tells you how much, like how big is the relation, like how bigger is the relationship between x and y, how strong is the relation. So it tells you the degree of relation between x and y. Is it a weak relation? Is it a strong relation between x and y? So that's the one. uh, how much is the degree of, and second, it tells you the nature of relation, whether it's a positive relation or negative relation. And we'll understand that in a moment. This R value, what we talk about, it always ranges between -1, and it goes like with a zero in between, and the maximum value is +1. So the range is -1 to +1. That's the range of R value. So R value can be anything in between -1 and +1. Say just some examples so that we understand what is the meaning, how do we understand and interpret the value of R. Uh, if R value comes as 0.0, anything between 0 till 0.3, if that's for R value, that means there is a negligible or almost no relation between x and y. So sort of not correlated. This is when you're getting an R value, R value. And when you get something like R value, generally the P value will be null. That means no relation. That's what R value range will also predict. 0 to 0.3, that is negligible relationship between, or pretty much no relation. When your R value ranges between 0.31 till 0.75, you have a weak or moderate relationship between x and y. That's when you start getting alternate for p value also. In case of R value, when it's greater than 0.75, it means there is a strong relationship between x and y, and you will also get an alternate in this one. So some examples of R value, just to get an idea, say I get an R value of 0.2625, or I could get an R value of 0.58, 0.91. So what will be my interpretation in case of R value here? My interpretation here, it will be there is no relation almost because it falls into 0 to 0.3. There's a weak or basically no relationship or negligible relationship. This falls into this zone, which is weak or moderate. So I'll say weak positive relationship because it's positive value. It's not showing a negative value. So weak positive relationship between x and y. This one will say strong positive relationship between x and y. Positive because there's a positive thing. Because r value can also come with negative values. R value can be like this, minus 0.28, minus 0.63, minus 0.88. Well, in this case, my interpretation is going to be same because it falls into no relation. That's almost like not negligible relation. This will be weak negative relationship between x and y. This is strong negative relationship between x and y. Now, what does this positive or negative relationship means? When you get a positive relationship, what does it mean? That if value of x increases, if value of x increases, y also increases. There's a positive relation. X increases, y increases. Say the number of hours you study and the number of the marks that you get in your exam. They are positively correlated, positive relationship between them. So similarly, I can say it's very, very like it's a say the faster you drive, the more number of accidents you see. So bottom line, there is a positive correlation. This if you drive irrationally, like at very, very high speed, the chances of somebody meeting with an accident increases. So if X increases, Y also increases. So there are a lot of things. Say when you talk about as summer approaches, the sales of ice cream increases, the sales of beverages and all those things, it increases. Why? The temperature is strongly correlated here with the sales, because as the temperature gets higher, it becomes a little hot. People tend to prefer ice cream or soft drinks and all that stuff. So sales and your temperature is correlated. So if X increases, Y also increases. That's what is all about this positive relationship. Here, when we talk about negative relationship, if value of x decreases, y increases, or like so the other vice versa, whatever you. So it's a reverse. Or if value of x increases, y decreases. So it's an inverse proportional. It has a opposite impact. For example, say okay, the relationship between mileage of the car and the age of the car. When your car age is new, that means the age is less, the mileage will be high. But as the car gets older, if the age increases, the car age increases, so does your would. So if age increases, the car gets older, the mileage reduces. There's a negative relationship. If x increases, y decreases significantly. So when you do a relationship, a correlation test, you could get anything. You could get a positive relation, you could get negative relationship, you could get no relationship also. So all these things are possible, like no relation, positive relation, negative relation, strong, weak, everything is possible. So correlation gives you some bit of more information other than just p-value. It tells you the nature, the degree of relationship, how big is the relationship. That's explained by the correlation test. While we do this, let me explain, so here this is my y, and say we have got this x as number of follow-ups. We have another x, which is CSAT score. So we want to find out whether customer satisfaction score has an impact with ticket closure time. Well, let's check. Stats, basic statistics, and we go down till correlation. That's where it's correlation. We click on this correlation. Okay, then here in correlation, we don't get two separate boxes. We get a single box. But always remember that the right practice is to put the X first and then the Y. So my X is customer satisfaction score. I want to check whether customer satisfaction score is related or is impacting your ticket closure time. So X first, Y second. Then you click on results. And here you check this pairwise correlation table. Once you check this box, click OK, and then click OK. You are done with this. Now, let's have a look at the test results. It will generate uh, some sort of graphical plot also, which we know as scatter plot. Let it come up. Again, it's taking some more time. Okay, that's there. That's scatter plot. So if you remember, we talked about this. It comes with a statistical test, a graphical test automatically. So correlation always works with scatter plot. So correlation test is what we've done. It generates a scatter plot also, which is graphical representation of this. So if I have a look at this, this is correlations. This is scatter plot. We'll come to that. We'll understand what is this. But let's first look at correlation. Just scroll down. P-value for correlation test. What does it tell you? Is it null or is it alternative? Is it null or alternate? Anyone?
Null.
Null. Perfect. So that confirms there is no relationship between your customer satisfaction score and the ticket closure time. And that's what your R value is also telling you. Because R value, if we just look at the table, R value is in this zone, 0 to 0.3. If you look at this, it says 0.003. That's an R value. That's Pearson correlation coefficient, which is here also. So pretty much this tells you there is no relationship. And if you look at this core scatter plot, how do you read it? Double click this graph, let it become big, and then go to add items. Add items. And here you go to regression fit. You click on regression fit and just click OK. A linear line. Now, keep this in mind. This is your customer satisfaction score, which is your X. That's your Y versus ticket closure time. It shows that, say, there's somebody had a like a CSAT score of 12.22, has a ticket closure time of 13 minutes also. A similar CSAT score, about 13, has a ticket closure time of 23 also. It doesn't matter whether my CSAT score is less or more. It practically doesn't have any relationship. He does it like my ticket closure time is less for the same CSAT score also. It's high for the same CSAT score also. When I look at this, say probably when my CSAT score is very high, 93%, still my time is less also, and still my time is high also. So that it doesn't seem to be playing any role. If like it's not like when your CSAT score is less, your time is high. And when your CSAT score is less, your time is low. That's not the case. It is evenly distributed, and this is what this line tells you. This is the regression line. We'll be studying about regression right now, like later. But yes, this line tells you there is no relationship. It's a flat line. Whenever you see a regression line going diagonally up like this, if the line goes up, that means there's a strong positive relationship. If the line goes down, this is strong negative relationship, and your line is flat, that means there is a no relationship. That's what we see here, no relationship or flat, because if it doesn't matter when you this is low or high, it doesn't matter. Let me give you another data set to like show you how does it work out. Give me a quick second. I'll just pick up a sample file. Okay, let's have a look at this. We'll quickly run through this. Sales and temperature that I was talking about. Let's have a look at this. Say sales is my Y, and I want to check whether temperature is related or not. So I'll do a correlation, numerical X with Y. So stats, basic statistics, and I go down till correlation. I will put my X first, which is temperature, and the impact of it on sales. Results, it's already checked now. Click OK. We'll come back to the chart later. Let's have a look at this. P-value confirms there is a relationship. It's alternative. Yes. Have a look at this R value. It is greater than 0.75. It's a positive. It tells me there's a strong positive relationship between X and Y. There's a strong positive relationship between sales and temperature because it's positive and it's greater than 0.75. So R value, which is Pearson correlation coefficient, that's what we talked about. Pearson correlation coefficient, when it's greater than 0.75, it's strong, like this. So this is this kind of value, strong positive relationship, which means if X increases, which is temperature, my Y will also increase significantly. It's a strong driver of Y. Have a look at this chart. It gives you same information. So scatter plot, we go to regression line, regression fit to get the line. We click OK. Okay, that's what it tells you. Diagonally up, if my x is low, my y is low. My x increases, my y increases. X increases, y increases. Y x increases, y increases. And as the x starts increasing, my y starts increasing. So there's a direct relationship between x and y. If x increases, my y would also increase. Strong positive relationship, which is depicted by this line going diagonally up. If I look at another example, and probably we'll be able to understand the how correlation works, this kind of the age of the car and the mileage of the car, that thing I was talking about. Let's have a look at this correlation for this one. Say we have age of the car, which is my X, and I want to check how will impact my mileage. Just click OK. We'll come to the chart later. Let's have a look at the p-value. There is a relation, a statistical relationship, yes. What kind of relationship? It comes with a negative sign, a strong negative relationship. If my age of the car gets older, it reduces my mileage significantly. It's a big negative driver. Have a look at this. A line going down, a diagonal down, add item, regression fit. We click get the line going diagonally down is a strong negative relationship. So this, when the car age was less, it was giving high mileage. As the car got older, it gave me lesser mileage. Car got older. If my X increases, it reduces my Y significantly. So that's how the correlation works. So you can get something like this, or you can get something like this also, which is a flat thing, pretty much no relation, flat line. That's a flat line, no relationship. I hope we all good with correlation. Everyone understands how correlation works.
Yes.
Okay, all right. So that's the once that's been done, pretty much we have one more thing that we need to look into is something called box plot. Box plot is something which we'll be covering. So when we did the two samples, so correlation comes with a scatter plot on its own, but we will be studying what is box plot, and box plot will help us take the decision easily. Be it two sample T or ANOVA will be, so whenever you do this test, you will be using box plot as a graphical tool. In this case, we don't have a problem because automatically you have a test and you have the graph also. Job done. Here you have to get this separately, ideally. So when you do the test of two sample D, you do ANOVA or you do Kruskal-Wallis. So that you can copy, paste, and update your statistical test, but you have to do a graphical test also to like as a supporting document sort of thing. So how do we go ahead and make a box plot? How does it help you to take decision? Let's have a look at this. We go to graph, we go to box plot. That's the box plot. Now we go with groups. We're comparing the groups, like two groups, more than two groups. That's where we will be using. So categorical data. Like have a look at this again. When are we going to use this? When there are groups, either two groups or more than two groups. So all categorical data is where it will be used. Box plot. So here we have got with groups. We want to compare the data with groups. Two or two plus doesn't matter, but they're groups. Click OK. This is where we put the why. What is your business problem? My problem is ticket closure time. So I select my ticket closure time that comes in here. What's your categorical against what? What are you testing? Well, I want to check whether ticket handler is that significantly impacting or not. Well, I select the ticket handler. So this is I want to check against the ticket handlers. Go down to your scale. When you click on scale, you get your reference lines. When you click on reference line, here it is where you put down your target, the management target, whatever your management wants. So probably the management has given us a target of 20 minutes. You cannot cross 20 minutes. If you cross 20 minutes, it is going to be called as a defect. It's bad. So you shouldn't cross 20 minutes timeline. That's what is mentioned. So whatever timeline is given to you by the management, the target given to you by the management, if it's a sales thing, put down the target. If it's quality, put down the target. So whatever target is there, just you put it here in the reference line and just click OK. Now that's how your box plot looks like. Now, how do we interpret the box plot and what decision do we take after looking at a box plot? Keep this in mind. One thing we got to look at when we're looking at a box plot, it is that your data is created in, like it's summarized in this box plot. The entire data from that you have, say Vandana's data is summarized in this box plot. Ravi's data summarized in the box plot. Okay, by the way, just want to check. Did we discuss box plot in your yellow belt? Anyone?
No, sir.
Okay. So how does box plot work? What is the purpose of box plot? Basically, it is a median based graphical plot. It works on median. So what it does in, like, if you remember, when we just go back to the median part of it, let me explain the box plot, because this is something which will be used whenever we plot the test. So when we have a box plot, I'll just rather doing this. Let me explain simple box plot, and then we'll be able to make sense out of this. So we'll come back to this chart. But let me make a simple box plot to explain what is a box plot and how do we read the box plot. So I put down the target, the ticket closure time, without any groups I'm comparing, just to understand what is box plot. I put down target of 20, and that's how it is. Now, that's a simple box plot to understand what is box plot and how to read and what meaning do I take out of it. So I take my cursor here and gives me some values here. That's what I have. Now I will just put down these values back on the Excel sheet to explain. Then we go back to MINITAB to understand this. It says Q1, it talks about median. It talks about Q3, it says IQ range, it says whiskers 2, talks about N. Let me just put down the values back here. It says 15.7237, then 18.7627. It says 21.5030. It says 9.42704, comma 26.20, comma 26.0608, and that's not that was not the one. This is 5.77934, and 181 is the N. So these are the values that I see when I look at box plot and I take my cursor here. So let's understand these values, and that's all we need to understand. Then we have some more values to look at, and the interpretation of box plot will be clear. First thing first, box plot is median based plot, graphical plot, median based. So it's not based on mean, it's not based on average, it's based on median. Median, if you remember, like whenever we have a median, it always sorts the data. Whatever may be your data, it will always sort your data, and the maximum data comes on the top. The highest value in your data will come on top after you sort it, descending order. The lowest value in your data will come at the bottom. So that's your data been sorted. That's what median does. Median will always sort the data. How we find median? By sorting it. In the center is the median. So that's how median works. Median divides the data into two equal parts, 50% below, 50% above. That's how median works. Median is the 50th percent, absolutely center value of the data. It's a position of the center in case of a data. Now, if I want to put down values here to just understand, let's kind of explore. So it says median value is this. So median is 18 point whatever this value. That's what we have median. So we're done with this value. So we know where is it coming from. Now, whiskers. Okay, if I go back to this box plot is also known as box and whiskers plot. You call it as box plot or you call it as box and whiskers plot. Meaning is the same. Now, this is box and whiskers are the tail. You call it as box and whiskers or box plot. So what it says, the tails, it's whiskers too. So the bottom tail and the upper tail. So the bottom tail and the upper tail. So it gives you the minimum value in your data, which is 9.42704. And similarly, it gives you the maximum value, which is 26.0608. That's what it tells you. So whiskers is what I am able to see from the data. So this is the lowest value in the data. This is the maximum value in the data, the median value. So this is absolutely 0%, absolute beginning, 0% of the data. This is your 100th percent of your data. And this is your 50th percent of the data. Median is the center. That's what it works. Is this part clear for now, everyone?
Yes.
Okay, now, if I want to find out another median in this area between 0 and 50%, what percent would that be in between? If I want to find a median here in the lower 50%, what percentage would that be? Median in this lower 50%, what percentage would that be? Anyone? But in the lower 0 to 50%. What is the center? 0 to
25.
50%. 25%. Absolutely, yes. So 25% is happens to be your center of the data. So which is here? 25%. So we have found another median in the lower 50% data. Similarly, we will find another median in the upper 50% data, which will be 75%. So median divides the data into two equal half, 50 and 50. And box plot, they work on quartiles. Quartiles. Box plot works on quartiles. Quartiles means quarter, 25%. So box plot will work on quartile, which divides data further into 25, 25 each. So 25%, this is referred as quartile 1, Q1, quartile 1, first quarter. From 0 to first 25th percent, that's my quartile 1. That's the value, quartile 1. Then from 25% to 50%, that's the next 25%. So 25% data here, another 25% data here. From 50 to 75%, this is called quartile 3, third quarter, which is coming from here. This is the value. So we got the quartile 1, sorry, we got the quartile 1, we got this value. N is equal to total number of samples. So we have 181 samples in your sheet. That's what it means. The only thing which is left out is IQR. What is interquartile range? This is referred as interquartile range. How do we get this? Q3 value minus Q1 value will give you interquartile range. So what is, if you look at this Q3 value minus the Q1 value, it will give you 5.77, whatever. So that's how we get this IQ range. IQ range is nothing other than the size of the box. This is 0% value. This point, if I want to get this line, just this is the 0% value. This is quartile 1, 25th percent value. This is median, which is 50th percent value. This is quartile 3, which is 75th percent value. This is 100% value. So data has been divided into 25%, which is here in this tail. 25% data is in the tail here. Another 25% is in this box. Another 25% is in this box. And another 25% is in this tail. So every tail and every box has 25% data. The only thing which we have to watch out for is the size of the tail and size of the box, which will tell you how big is the variation in that 25%. If I look at the tail is very big as compared to the box. So this 25% data has high variation. This 25% data has less variation. This 25% data has less variation. This tail is little bigger also. So there is little higher variation here also. But in the center, 25, 25, these are very, very compact. The variation is less. If I want to go back and look at the data, that will help me further understand the same thing. This Q3 minus Q1 is nothing, this value minus this value, which is going to tell you the size of the box. Q3 minus Q1, which is interquartile range, IQ range, what we calculated, it gives you the size of the variation in the box, which is 5.77, whatever we're measuring. So this size of the box. Coming back to what do we study here? This is the variation we're studying. So range is maximum minus minimum, the lower 25%. What is the variation? Maximum minus minimum. This is the variation in the tail. The tail is long, it's a long tail, and it tells me this is the variation in the tail in the language of range. Let's look at the center, the box. First, lower box. This is what is the variation. Yes, I can see it's almost half of the tail. So variation is very less in the center, in the lower 25% of the box. The lower box has got less variation, same 25% data. Number of values are same in every tail, every box, but the variation is very high in the tail and variation is less here. If I look at the next 25%, which is the upper box, this maximum minus minimum. Well, the variation is even lesser in the upper box. So right in whenever we talk about the box has very less variation. Around the median, 25% here and 25% here, variation is very less. But tail has a huge variation. Let's look at the top tail. This minus this. That has also high variation. But yeah, lower 25% is very, very high. So pretty much the only thing we got to look at is the size of the box and size of the tail. That helps me understand that how much of variation is there in every section. Now, that's what we got to keep in mind. Every box, every tail has 25% data. Now, keep this in mind. This 20 minutes is the target given by the management. That you cross 20 minutes, it's a defect because time related data. If you cross 20 minutes, I'll call that as a defect. Now, just by looks of it, prima facie, without getting into any bit of further, just approximate number. What is the pass percentage in this data? Anyone wants to pitch in? 20 minutes is the target line. You cross 20, it's defect. What is my pass percentage? Just by looks of it. Anyone? Whatever we have understood about box plot, size, shape, whatever we talked about, what is my pass percentage? Just by looks of it. Anything more than 20 is fail, anything less than 20 is pass because time, lesser the better. Anyone wants to pitch in, please? Any vague idea about this? Okay, let's have a look at this. Anything more than 20 is fail, anything less than 20 is pass because it's time related data. Time lesser the better. This tail has 25% data, which is pass. This is less than 20, which is pass. So 25% pass. This box has 25% data, which is also pass. It's less than 20. It's below the line. This box has 25% data. I will say like it's bisecting almost midway. So about 12.5% here and 12.5% there, roughly. So this 12, 25 plus 25 plus 12, 12.5, but 62.5% is pass and remaining is fail. That's how we interpret it. Is that clear to everyone?
Yes, sir.
Okay. Now, the last thing which was left out in a box plot are these signs, these symbols, outlier symbols. This says your time, lowest time is 6 minutes in the data, and you have highest time of 33 minutes. Well, that's different because what we saw that lowest time was 9.4 and maximum time was 26. Whereas this is showing that there is a lowest time of 6 minutes and a highest time of 33 minutes. So box plot has automatically identified that these are exceptionally high or exceptionally low value. That cannot be mixed with the data. You need to study them separately. So box plot has this additional capability to understand an exceptionally outlier value. And that's why it has thrown these values out of the data to be studied separately. That cannot, you can't let one or single value or couple of values to spoil your data. Most of your data is like this, not like this. So this has been thrown out. And when you see outliers, these data points need to be studied separately. When you take your cursor, it tells you what row number 153. Go and investigate like who was the culprit, who took so high time, why did it happen, and look at this row number 167. Somebody did a phenomenal job of 6 minutes. How was that possible? So we can go and investigate row 153 here. Will you go and see who was involved and all that? Say 153, 33 minutes. Nitin was the ticket handler. Well, I would like to understand what happened on this transaction. So these are separate things which needs to be studied separately. I hope we are getting this, everyone.
Yes, sir.
Okay, have a look at this box plot back then. This is where we compared all the ticket handlers. Who is my best ticket handler here? Who's the best ticket handler?
Nitin.
No, best ticket
Vandana.
handler.
Vandana.
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 Absolutely yes.
Okay.
Absolutely yes. Vandana. What is the pass percentage for Vandana? Roughly, because we're not looking at numbers. Roughly. Just rough estimate, looking at the data. You have 20 minutes of cutoff limit.
85.
I'm sorry, how much?
85.
Yeah, I would say I would agree with that. Like so roughly 85. Yes, because 25% this is pass, 25% this is pass, 25%, this is pass. So 75% we are done. And then tail has 25% data and some, what I would say 10% here, 10 here in 15 years roughly. So about 10% here. So 85% I would still say yes. Her pass percentage is 85%, fail percentage is 15%. And similarly, we can compare. So she is my best ticket handler. And now that's not coming from gut feeling. I'm not taking any gut feeling based decision. I'm looking at data. The data is creating. You can look at numbers and give the actual fact based feedback to people. So a lot of people use these graphical tools because these are self-explanatory. You can give somebody a feedback based on number. You don't want to be using like emotion-based feedback that this is good and that is bad. No, data speaks for itself, and that's what we're looking at. You can do this comparison with anything. Let's say if I have this box plot, let me just create another box plot graph, box plot. I want to do it with groups to do comparison. Uh, Ticket handler, let's keep ticket, let's remove this. And I want to do it by gender. I want to see male or female, who's better. So I check this one. What does it tell you? Male or female? Who's doing a great job here?
Female.
Absolutely, yes. Females are doing a phenomenal job. Males are not. And that's what if you do the statistical test, two sample t, you will figure that same. You'll get the same values. Similarly, say you do similar activity, and you can do like multiple also. Let me show you one. Say you have got user say qualification, and I would like to look at by shift also. So I can do combination also. By shift, I would like to see how people are doing. So I have got postgraduates who are doing horrible, but not in morning, in the night shift. They're doing horrible, absolutely bad. See, rest everyone is still fine, still fine. But this one, that's where the biggest problem lies. So postgraduates in the night shift, they are the one who are looking bad. See, if I just remove, just let me show you. Like if I remove the shift, you might just say my postgraduates are bad. So this is where if I look at postgraduates only, well, they are looking horrible because this graduate is good, undergrads are also good, postgraduates are doing horrible. They're bad. Now I would like to further drill down into postgraduates and see, are they all bad? No, that's when I probably added shift and say, I want to check shift-wise postgraduates. And that's when I figured out, no, no, no. The problem is not with all the postgraduates. The morning ones are great. They're doing best. But here is the challenge is only with the night shift ones. Night shift postgraduates are the ones who are doing horrible job. And I really need to understand why. So yes, that's what you can do combination. You can try out various stuff. Again, you can use manager along with the trainer. By manager also you can compare. So math can have up to 4, but it becomes too clumsy for when you add too many. Like I'll just have a look at this. Becomes too clumsy, but it helps you to further get an idea. Who is this Pooja? Pooja is the manager who's managing all those night shift postgraduates. Probably she needs to be reassigned to something else because Pooja does a great job in the morning shift. Manager Pooja, morning shift, graduates, she is doing a phenomenal job. So it's not that she's bad, but probably she's bad at managing the postgraduates and specifically in the night shift. So probably a job reallocation needs to be done because if I look at this one sign, there's one candidate only, which is a night shift postgraduates, but handled by Reena, and is doing a phenomenal job. Probably why not move every person in the night shift postgraduate to Reena because she's able to manage that single postgraduate in the night shift. Great. Well, other postgraduates who are reporting to Pooja, they are doing horrible, absolutely bad. So some bit of more deep dive, like how much you more want deep dive into data, you can definitely try out this. But it's just about now getting used to the box plot. It is a very, very good tool. And hence, whenever we use these tests, be it your two sample t-test, or you do ANOVA, or you do a Kruskal-Wallis, you always use box plot along with that as a statistical test. Is this clear to everyone?
Yes, sir.
Okay. Now, and pretty much one more thing which is there in the analyze phase before we move on to the improve one. Again, we'll have some more tests in the improve phase also. But before we get there, there's something called 7QC tools, 7 quality control tools, which are graphical tools, and some of it which we have already covered, but we should know all of the 7 quality control tools which are there. say 7 QC tools, which are very commonly known lists. One is histogram, second is check sheet, you have flowcharts, you have got scatter plot, you've got fishbone diagram, you've got Pareto chart, and you've got control charts. So these are globally known set of 7 QC tools or 7 quality control tools. Histogram, like, can anyone tell me, like, histogram, what is histogram? Is anyone there? Like, I'm sure this is something which we should have covered in the yellow belt at least. Yes, it's histogram. Do we know what's histogram? Anyone?
Sir, it is a graphical representation using bars of data using bars of different heights.
Okay, yes. So histogram, when you look at your data and then you plot the data graphically, it forms this bell-shaped curve sort of thing. So when you say you have got this data, if I make a histogram, that's what it is. So it helps you understand the process data in terms of bars. As you correctly mentioned, it will help you understand the process data graphically. When I make a histogram out of it, it helps me understand where is my center of the data, what's the average of the data, and also helps me how much it is spread out. What is the variation in the data? So that's how it helps me understand. When I look at my histogram, it helps me to understand the centering of the data and the variation of data. If it's too scattered, that's huge variation. If it's less scattered, it's very compact, the variation will be less. So if I look at a different kind of data, like say, if I'm looking at say customer satisfaction score, I'm plotting a histogram for this. Look, it's a weird one. It's a weird kind of histogram. Well, some people have scored less, some people generally score here. Most of the people are kind of scattered around 75 and above. So basically it gives you an idea of how your data is kind of staggered in different sections, and how many people, the height of the bar tells you how many people scored in that particular range, like between 62.5 to 67.5. There were 32 people who scored CSAT score between this. So it tells you the frequency of every range. Basically helps you study the data, the center of the data, the variation in the data. And this is how your like histogram helps you to kind of further and understand and analyze your data. So to get started, whenever you want to look at the data, study the centering, which is the mean, median, mode sort of thing, or for that matter, standard deviation, we will be definitely looking at histogram. So that's plus minus one, plus minus two standard deviation. That is nothing other than histogram. When you plot that graph sort of thing, that's what we are looking at, histogram only. So this is when we plot this, your plus, this is your mean, your 1, 2, 3, minus 1, minus 2, minus 3. That's what you're studying, histogram. This is your histogram only. So histogram helps you to understand the process data, because when you put your line, I see what sigma level, you can only calculate this using histogram. You have your average and the standard deviations, which is variation. Histogram is the base for calculation of sigma levels. If you don't have your histogram, pretty much you don't calculate sigma level. So that's how your histogram works. Coming to the next thing, check sheet. Anyone would like to suggest some examples of check sheets? What is a check sheet? Anyone?
So check sheet is a uh, document in which we updated the regular data collection.
Absolutely correct, Shivam. Absolutely correct.
So
Check sheet
it
is
keeps a record in terms of frequency.
absolutely recording data against set variables, whatever you have. Like you say, the bigger, like some of the common example, your attendance sheet, that's a check sheet. When you maintain present, absent, late, or whatever, that's a form of a check sheet also. Check sheets are of different types. Even your to-do list is was type of a check sheet. Bottom line, you have a certain set of things, and you are recording values against those variables. Like this is also a check sheet. You had your y and your x's, you collect data around those. That's a check sheet. People in housekeeping, they maintain a log that it was cleaned at 8 o'clock, 9 o'clock, tick 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 sort of thing. That's a check sheet. Check sheet is very, very manual way of collecting data, but trust, very, very effective, because you won't, if you don't have your check sheet, how are you going to get the data? So yes, data collection will happen when you have your check sheet in place. So every organization, every department should rather have their own check sheet. What it does, you are able to collect all those data points which you need to collect. You would not forget anything, because generally you keep it like in terms of like, okay, I remember everything. That's a very risky position to be in. So it's important to kind of put list down all the things which you need, and you will know for sure if you're missing out something. It will not, you will not miss it by chance, by error. You will miss it because when you know for sure I can afford to miss it. So it will, you will not make mistakes. It will be a calculated like a logical decision that, okay, today I have 15 things to be completed, I don't have that kind of time, so which one I can leave. When you have that list in front of you, you can take that rational decision. But when you just kind of like relying on the memory, then you will make mess out of it. So check sheets are very, very important, generally used across industry. Flowcharts is something which we are very much familiar to since our schooling days, and we got into flowcharts. When you made a SciPoc chart initially, when we talk about high level process diagram, the flow of the process, that's when we basically were dealing with a flowchart. Flowcharts are essential when we're going to implement lean. You want to look at process from end to end. Flowcharts will be required. So that's the basic stuff when we prepare a SciPoc and then make a detailed process map. That's a flowchart. Scatterplot, we just studied using correlation and the scatterplot, we talked about it. Fishbone diagram, we have already covered, like when we found, like started the measure phase, we wanted to understand what are the possible causes. We did a fishbone diagram. Anyone can tell me like what is Pareto chart? Anyone? What is the other name of Pareto chart?
Sir, 80-20 rule.
Absolutely, 80-20 rule. So I'm sure we all are familiar with Pareto chart, everyone.
Yes, sir.
And the control charts we will be covering in the control phase. That will be tomorrow. We'll be covering up control charts. But yes, let me quickly show you how to do Pareto chart in MINITAB. It's easy. Pretty much we should know that. So let me just quickly go back to Pareto chart, just the sample data. You need to have data in this format, like type of issue and how many times did that issue happened. That's how you need the data for Pareto chart. The type of issue and the count of issue. Just copy paste this data, put this on MINITAB, and say this is the data. We go to stats, go to quality tools, and in the quality tools, the second one is Pareto chart. Click on Pareto chart.
Sir,
Yes.
sir, we have to use MINITAB in our exam also.
No. It won't be required. See, it's just in the exam, it's not going to be required, but technically you should practice and get used to this.
Okay, sir.
Yeah. Frequencies in the counts. So defects and defects, frequencies and counts. So that's how you put it, and you want to analyze. See, there's an option says we combine after 95%. We would not like to do that. We would like to see everything clearly. We don't want to combine any values together. We would like to see it everything. Let's click OK. You're done. Pareto chart has been done. So this is all the issues are in descending order. The maximum issue, second highest, third highest, fourth highest, fifth highest. So all been in a descending order. That's why you get the count. 274 issues of missing screws, 59 issues of missing clips, and so on and so forth. It's till descending order. This tells you that 64.8% issues are coming because of missing screws. 13.9% issues are because of missing clips, and so on and so forth. Everyone's contribution to the total number of defect. And finally, then you have a cumulative percentage, which is like this alone is contributing 64.8% issue. You add 64.8 plus 13.9 for the second one. The total is 78.7. So these two together are contributing 78.7% issue. You add 10.2 to that, so that makes it 88.9. So these three together are contributing 88.9% issue. You add 4.5 to it, it becomes 93.4. So these four together are contributing 93.4, so on and so forth, like till 100%. The same line values are plotted in terms of this cumulative frequency line. These same values at the bottom are presented in terms of line. Now, as you said, 80-20 rule. So it basically means that 80% of your issues will come because of 20% reasons. How do I get that line of 80-20? I can right click here in the chart, in the graph, go to add items, and here it says reference line. When I click on this reference line, it's going to give me two options. One, it says primary scale, which is this. And then it says secondary scale, which is this. And we are dealing with percentage, so I'm looking at the secondary one. I'll put in 80%. Where's the 80% issues? Click OK. You get your line. Here is where it's bisecting. Somewhere just next, because we know 78.7 is this dot. Just next to it will be 80%. So practically don't, it tells me that 80% issues are right here. So you want to highlight that, you can use this bar, this oval sort of thing, and then you can kind of plot this. 80% issues are right here. So you fix these issues. Don't run after every possible issue. Just work on these major issues. The problem, most of your problem, 80% problems will be solved. Don't need to run after every possible thing. Just have your work on these issues. So data is ready. Just share it with management. So these are your 7 quality tools, and along with these 7 quality tools, the additional one was boxplot. Boxplot is not a part of 7 quality tools. This is an older version, but now it is the most like heavily used tool is your box plot. Out of all these, like practically control charts are definitely used, and like scatter plots are used, but for everything else, like practically you need a box plot is something as a graphical tool. It is the most popular nowadays. So this is the older version, like 7 quality, 7 QC tools or 7 quality tools. So pretty much that's what it is. Now from analyze perspective, are we all good with analyze phase? Because next we will get into the other one, which is the improve phase. Is it okay with everyone? I would request you to please just confirm in case we are good with it. We shall move forward.
Yes, sir.
Okay. I have. I guess everyone, most of us are back here already here. Let me just quickly tap in. Okay, that's the link. Some of the files that we'll be using today, even including the Excel sheet that we worked on yesterday. So it's there in the link. Some of the files that we'll be using today, it's there in the link. So you can click on it and it'll get downloaded, which will include some of the files that we'll be using now in the improve phase. Now, improve phase starts with the basic fundamental of regression. Now, regression is another test that we will be dealing with in the improve phase, because at the end of analyze phase, you already know which ones are root causes. You've done your testing, you have performed your statistical analysis, so you know which one out of this list is your real root cause why you're facing the problem. So you know your problem, you can solve it now. You have the business problem identified, you know why you're facing the business problem and what are the actual reasons. But now, before you hand over the process to the process owners, because you're not the technical expert, you're not the process expert, you are there from a Six Sigma perspective. You're trying to help them with the project management, quality management, statistical knowledge to help the core technical people get the required information as to what is causing the problem. You tell them the problem, they will have a solution for you. But before we hand over the process to, or tell them, share the details of the analyze phase with them so that they can get going, we would like to ensure that some bit of additional knowledge we can share with them. So we use regression. Why do we use regression? It helps us understand which root cause is more important, which one is less important. That's simple as that. That's what it helps you to understand. So in regression, we'll be studying 2 types of regression. One is simple regression, then we have a multiple regression. So before we go down to the test and everything, let me explain what's there, what information will we be checking there when we perform the test. We get a P in this simple regression. We test 1x with y at a time. With 1x with y, we check. We get a p-value for that. We get r square, and what's that? We'll understand. We get a linear equation. These are 4 pieces of, basically, that's what we get in simple regression. In multiple regression, we test multiple x's with y at the same time. We get p-values because they're multiple x's. We read r square adjusted. What's that? We'll again understand. And we get linear equation. So these are basic stuff that we will be getting and we'll be reading and understanding when we perform the test. Linear equation is something which we skip in simple regression because it gets repeated here, and it makes more sense to read a multiple regression linear equation because this is like it alone, it doesn't make sense. So let's have a look at simple regression. So in simple regression, we have this Excel file that's there in the link also. We click over, okay, let's open up this file, simple regression. So I'll just copy paste this data and I'll show it, like explain what's there, what are we trying to establish here in this data set. So here, basically what's happening is there's a HR firm, say there's a HR firm which is trying to establish some sort of mathematical model, some sort of fact-based decision-making model, which can help them offer salaries to the candidates. So there's a job firm, like any kind of recruiting firm or any kind of firm where we have some recruiters, and these recruiters interview candidates almost every day, and they offer salaries to different people. But again, somebody gets a higher salary, somebody gets a lower salary, and you ask this person what was the reasoning why you offered the next salary, probably will not be able to explain what are the logic basis, what was the basis behind it. No. So a lot of companies across the globe, they have come up with some sort of mathematical model to help them with the right salary, and this can be done for anything, like anything. This is just an example. So this logic can be implemented for anything and everything, any business problem. So in this case, they're using for determining salary. What is the right salary which needs to be offered to the candidates? So we, like the people who are core technical experts, somebody felt like, okay, well, gender wise, I think there will be an impact. So male or female, somebody feels that females get more salary than male. Some people feel that no, males get more salary. Okay, well, that means you probably want to say that the organization is gender biased. Well, I don't want to say anything. Let's check. Let's test it, and we'll know whether there is a influence of gender or not, male or female. Does that influence the decision as to how much salary will you get? Well, let's check it out. I'm not being gender biased now. Some people felt like how well you do in your interview, that could be a critical factor. So if you do good, you'll get a better salary. If you don't do well, then you get a lesser salary. So uh, so this organization has been conducting some sort of interviews, some assessment, so through some sort of examination. Say, so some score is being generated based on that examination. So this was suggested by a lot of technical experts, and so we included it. I'm not trying to be judgmental here, but let's be included it. But some people also said, no, 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 experience matters a lot. If you have good experience, you'll be offered higher salary. Somebody who doesn't have good experience will be offered lesser salary. Okay, we included that also as a criteria. So we don't want to be judgmental about anything that this is right and this is wrong. So unless we have tested. So now we will start with a regression to check whether are these the real root causes which is impacting the decision of salary, and if it is, what kind of decision, how much, which one is more important, which one is less important, how much is it influencing the decision of salary. Let's understand with a simple regression first. Simple regression means 1x at a time, 1x with the y. So let's kind of test this. We go to stat, we go to regression, and we go to fit regression model. Stat, regression, fit regression model. We click on this. Now, response as your y, the business problem. So here my decision is all about salary. Okay, let me just explain. While we're doing this, so these people, what they did is they checked out historical data. So these people were already hired. They are working with our company or not working, but they were hired at some point in time by the organization. So we want to use our historical data to make future predictions. That's what we try to do here. Somebody at some point in time in our historical data, so we looked at HR hiring files, and we got to see that some female was hired at some salary of 88. Female, when she appeared for job interview, she scored about 4.5 out of 10. And when she was interviewed, her experience was 11 years. Similarly, some male candidate was offered 77.3, who scored 7.8 in his assessment, and he had about 6 years of experience. So these people were hired already. They are working with the company or not working, doesn't matter. But historical data is what we are trying to assess to make future predictions so that we can come up with some sort of mathematical model. So salary is what we try to predict here. Continuous predictors, all numerical ones. Categorical will be all group ones, text-based. Number-based, text-based. So let's find out continuous predictors one at a time. That's what we're looking at. Simple regression first. So interview score, is that impacting your salary decision? Let's click OK. And so it comes with this equation, linear equation. We've already discussed about that. Linear equation, we're going to skip. Linear equation is what we're not looking into. In case of simple, we'll come back. It'll get repeated here. So we'll come back and discuss it when we do multiple regression. But first thing, what we are looking at, interview score. Let me just make a note of this interview score. And what information do we get from interview score? Let's have a look at this. The equation we're skipping. P-value. P-value is what tells us, yes, is there a relation? Yes, absolutely. Interview score has a relationship with your salary. So it's related. And we have that evidence, statistical evidence, yes. So it's no longer gut feeling. Yes, we have an evidence here. There is a relationship of X on Y, which is interview score on salary decision. There is an impact. Let's note down one more thing, which is R squared, 52.98. Let's make note of this, 52.98, which is R squared. We'll understand what's that R squared. So we got p-value. We tested 1x with y. We got a p-value. We had R squared. This we have skipped. Let's do one thing. Let's go back and change this to experience. Let's check experience impact. Equation, we skip. P-value, yes, there is a relationship. We confirm that. Perfect. R square, 83.26%. Well, this is experience and 83.26. That's my experience one. Let's go back and do another simple. So we're done with the numerical ones. We're done both with those X's. Categorical one, it says gender. Let's see gender-wise. So categorical is what we'll use here. Click OK. Equation, we're going to skip for now. Doesn't. P-value, that's null. Null means there's no evidence for a relationship. So hence we can say that my management is not gender biased. There's not enough evidence for you to claim that management is gender biased, male or female. That influences salary decision. No, sorry, we do not have any supporting information for that. Still, let's have a look at R squared. 10.06. Well, R squared. This is gender, and this is 10.06. Now, what is this R square? R square helps us understand the degree of variability X explains in Y. In nutshell, in layman language, how much of impact X makes on Y. That's what it is. It is. How big is the root cause? So as per this, it tells me that experience is the most critical factor in deciding salary. It is a driver. Yes, it's a big driver. Second big. And if at all, this 10.06 has some relevance, probably third. But we get alternate here. We get alternate here, and we got null here. Null means no relation. That means this is negligible, nothing. And we'll understand this. It'll get clear. It'll get clear why this is nothing and still null. Like you're getting 10 points. What is the relevance of this? How much is that? How big is this? And how big is this? We'll be able to understand when we look into multiple regression. But for now, that's my simple regression part. Multiple regression, we test multiple X's at one time. So we test these. So let's get them back. We are, say, in case you have more X's, you can test them at one go, but it's advisable. Test in a batch of not more than 5. So you have more than you can do it in batches of 5, 5, 5 sort of thing. But because it becomes too clumsy. So I have got 3, so I'm just testing everything at one go. Click OK. Equation I'm going to skip for now until we have. So p-value, score, yes. Experience, yes, it has impact. Gender, it's null. So we have an evidence, we still don't have the evidence that gender is impacting. When we are talking about multiple regression, we don't look at R square, we look at R square adjusted, what it says. So let me just go back here. Here we get for all, when we put everything together, we're getting an R square adjusted of 88.84%, which is R square adjusted. Now, what is this R square adjusted? Now, these were the individual impacts. When you test everything at the same time, what you're trying to find out is, see, when there is an interview happening, you're deciding someone's salary. All these forces are acting on the decision of salary at the same time. So interview score is also putting in an effort or impact on the decision of salary, whatever is this impact. Experience is also making some impact. Gender, if at all, is making some impact, but it is all these forces are acting on the decision Y, which is salary, at the same time. What is the net output, the overall output, the final output of these factors put together? That is explained by R squared adjusted, because they are not happening in silo. The interview is not, the salary is not coming in silo. It is the, if at all, gender is influencing, the interview score is also influencing, experience is also influencing. What if some is positively impacting each other, something is canceling each other's impact. Ultimately, what's my net final impact because of these three factors? It says 88.84%. Well, what do we do is, now we take off just to get an idea. I want to see how big is the experience. How big is the experience? Let me remove experience from this model. I have removed experience and I want to see the loss in the quality of the model, loss in the decision making or prediction of the model by removing this particular factor. If I remove this particular factor of experience, I will see what is the drop I see in the quality, in the overall impact. Let's see. I'm going to put this as loss of experience. So if I remove experience from the model, which is 88.84% effective, let's see how much do we lose. Well, that's significant drop, 55.74. It says 55.74 is the net remaining impact. So there is a loss of 33.1%, which is a huge drop. You have removed a very, very big root cause, a very big factor influencing the salary. So this tells me it's a very big root cause. Let's put this back, and you're just trying to understand, remove the interview score and see what is the loss of interview score, how much is the role it's playing in the overall decision of salary. So we click OK. Let's see. 82.43. Well, this is loss of your interview score. In case you remove interview score from the model, it says 82.43. But that doesn't seem to be a very big, but still, okay, 6%. I'm not saying it's not a big value, but not that big as this one. So this is definitely a very big factor. This has got less role to play, yeah, but still a significant one. But this is also alternate, this is also alternate, and these are significant. 6% is not small. So we'll put it back. So let's see, we have got interview score back. Let's see gender, remove gender and see what's its role in the overall model. 88.78. So remove loss of gender, 88.78. Let's see what was its role in the decision. 0.06% was the overall. That's why it was coming as null. This 10.06, which was the individual impact, so as to say, overall was playing a role of only 0.06% in the overall decision criteria. So we've got a clean model at this stage. That's where we will end. In terms of p-value, all alternate, yes, we've got a clean model. We've got R square 88.78. That's my final model. So I'll remove gender because that was null, and I'll work with only the real root causes. That brings us to the equation. That's where we will understand the equation part of it. Now, when we talk about linear equation, multiple regression, we get salary here. Salary is equal to 53.22 plus what it says is 1.754. Experience plus what it says 2.105. Interview score. Now, this basically works on the equation of y is equal to c plus mx. That's the basic core function behind this, which is the linear equation. Y is nothing other than Y is your salary, Y is your business problem that you're dealing with. C, C in statistical language, it's called as intercept. Now, to understand in layman language, what is the meaning of C? It is the minimum value of Y when value of x is 0. What is the minimum value of Y when the x is 0? We'll understand with the calculation also. We'll get this. But keep this in mind. This is the bare minimum when what will be the value of Y when there is no x. Simple, fixed, constant value. That's a layman language. M in the statistical language is called slope. In a layman language, to understand this is the multiplier of x. Whatever is x, so how much do you multiply that with? What is the impact factor of that x? X is x. So if I want to read and interpret this equation, how does it translates to? Your salary is going to be constant at 53.22, which is constant value C. Then it says 1.754 is the multiplier of experience, which I'm keeping it blank. This here, this is experience. So this is when it says 1.754 experience, that means it's 1.754 is multiplied with the experience. That's what it means. 1.754 experience means this is getting multiplied with experience. So for now, we don't have any value here. Let's keep it as it is. Then it says 2.105, which is multiplying with interview score. That's where it's getting interview score. Again, this is being multiplied with 2.105, and this has been multiplied. Now, what you see here is salary. It says salary is equal to 53.22 plus, it says whatever is the multiplier of it, plus whatever is the multiplier of this score, plus. You add everything, you get your salary, finally predicted here by the model. Now, let's understand. Somebody comes in for job interview, and during the job interview, this person scores 0 out of 10. The interview score 0 out of 10. Nothing changed. 2.105 multiplied by 0 remains 0. And is a fresher, just out of college, no experience, 0. This multiplied by this remains 0. This multiplied by this remains 0. That's your fixed constant value. Minimum value of your Y when your value of X is 0. That's what we talked about. If your value of X is 0, what is going to be the minimum value, the base value of Y? That's what it remains, 53.22, because it is getting multiplied by 0 and we're getting not constant value. That's what it's fixed bare minimum salary that you will be offering any which ways to everyone. Now, somebody else comes in, say with a 6 years of experience and scores 7.5 out of 10 offer the salary. That's a calculator ready for you. Somebody comes with a 7.5 years of experience and scores 2 out of 10 offer the salary. This is being multiplied, whatever the impact. It is created out of your data, your own historical data, for you to predict your future, like business pro, whatever the salary here. So that's how regression help in predicting the future values. Is that clear to everyone? How does it work? The regression part of it. Is that okay with everyone? I would request you to please confirm.
Can you please repeat again?
Okay. So this salary, this equation part, are we talking about this? Is this the equation that you're talking about?
Yes, sir.
Okay. So this equation, it says salary is equal to 53.22, which is constant value. C, Y is Y salary. C is this 53.22 plus multiple of X, MX, multiple, this equation we got from the equation, multiple of X. So we got multiplier of every X, multiplier of X. So 53.22 plus, it says plus, then 1.754 multiplier of X, whatever is the value of X, then 2.105 multiplier of X, What is the value of x? So we just need to, you, this has become a cap, this is coming from your own historical data. This equation was, like, you have your own organization data. It has predicted this equation for you, that if you want to predict your salary, you have these x's, you just change the value of x's, it will help you predict what should be your right salary that you need to offer to your candidates. And we just making the changes in these x's, and it's getting multiplied by these values, which is giving us the impact of these x's on the decision of the salary. It's created from your own data. So this 53.22 remains constant, 1.75 remains constant. The only value which is changing is the experience. The only value which is changing with this interview score, because every candidate will come and will have a different interview score, will have a different experience. So it will help me come up with a mathematical model so I can predict my why. So it's not gut feeling based. It's coming from the data itself. And keep this in mind, this is going to be applicable for the same company, same data. If you're talking about a different company, they have to create your own model. This is applicable for only that company where this data has been, like, because this data was created from the same organization. It's true to them. It may not be, your equation may not work in my case, because my company culture, customs, historical process, everything is different from your company. It has to be very clearly understood that data needs to be this regression, like people have created such calculators for salary, for attrition, for a lot of factors like this. It's just about kind of reusing your data in a more logical way. You get to understand which, ideally I'm concerned with these values, because this helps me understand which one is more important, which one is less important. Accordingly, I will be able to emphasize on the x which are more critical x's, and work on the x's which are less critical in a real problem when I'm going to improve my business problem. These are my business problem, these are my x's which are impacting my y, and I have validation for that. But how big is that x? I will be able to look at r square, and that will help me understand that. Is it clear now?
Yes, sir.
Perfect. Now, at this stage, when you have got your regression understood and pretty much we've completed the regression part, this is the stage where you generally give it out to the process owners. You give it to the process owners to brainstorm and find a solution, because you have now the problem identified, and you also have told the process owners, the subject matter experts, as to how big is this particular root cause. It is a small problem, it's a big problem. You have this x, this r square values available. Now that's when you come up with the action plan for your team. What are the steps which you will be performing in the improve phase? First, you will identify solutions for the root causes. Identify whatever you root causes, validate whatever problems you have, root causes, whatever you found. You need to find out solutions, what needs to be done to fix this problem. We'll talk about that. Once you have got list of solutions, you need to prioritize the solution. So you cannot implement all the solutions at one time. So you need to have a right priority, which action plan will be implemented first, which will be implemented second, so on and so forth. So there has to be a logical priority of implementation of those action plans. Once you've got the action plans ready, then you can't just go and implement this action plans. You will be talking about risk management plan. What if something goes wrong? So risk management is done using FMEA, and prioritization is done using X and Y relationship matrix. That's what we'll be studying. Uh, and then once your risk management is covered, pretty much you have a list of action plans, which you have prioritized in X and Y relationship matrix. You are ready, your team is ready, but you would like to safeguard and vaccinate those action plans. You don't want the action plans to fail. You cannot afford your action plans to fail. They must work, because if they work, you'll be able to improve your root causes, which will improve your business problem. So risk management comes as a very integral part. Next, when your risk management is covered, that's when you go for the next activity, which is about implementing solutions. Now you are ready implementing solutions, but you always implement on a pilot scale. You don't go full throttle, changing everything. You want to test and try, because I don't know what if whatever we're trying, it backfires. What if it turns out absolutely wrong? I don't know. So we need to implement on a pilot scale and a small scale. When you implement a solution, some sort of strategy, you want to see whether it's improving, it's getting better or not. So to check project progress, whether it's improving, did you achieve the target or not? Because you started the project with a target, the manager must have given you a target. We use one sample t-test for validating, did your project improve or not? Once you are able to validate and check with one sample t that yes, you have improved and your process has improved, then you go for some before and after analysis. In before and after analysis, you use a paired t-test, you use a box plot, and you use old versus new sigma level. That's what you showcase to the management that, yeah, I have a validation that we improved the process. I can show you before and after statistical tests, which confirms that the old and new process, they are significantly different. We will be showing that using box plot also, and we'll have some old and new sigma level comparisons. That will be enough evidence for the management to say, oh, well, okay, you have definitely improved this, and you seek an approval for full scale implementation because you have given the like, confidence to the management that yes, we have achieved that level of understanding or skills, and we are have improved a small project like a small scale. Now let's go and replicate this entire knowledge and the entire process and improve everything overall. So you seek for an improvement approval, and you when you go for full scale, so go for full scale implementation and repeat same steps. So you got to improve the overall process and validate the same using one sample T and pair T, that did your overall process improve or not. So once that is being done, your improve phase gets over. So you will be, you'll have your overall process improved and validation will be there. So your management pretty much whatever they wanted, they would have achieved that desired target, the overall process would have improved, which brings us to control phase. We'll be talking about all those terms which we talked about, just giving you the flow of it so that we know what do we do in every phase. So once your action plans have achieved the desired target, the managed process is improved, you need to obviously close the project also because you have improved the process already. You need to improve the close the project. For that, there'll be a couple of things which we do work on. One is a control plan, control phase, and second is called lessons learned documents. So these are two things which we work on. The lessons learned document, to be very precise, it's nothing other than a submission of project report. Basically, you will be submitting some sort of project report, some sort of what you call a SWOT analysis, when you just mention this, what went fine, what could have been done better, goods and bad, like everything about the project, just a summary report of your experience about the project. This helps the management understand what they could have done better. That will help them as a guideline for future projects. That will help them. Other than this, you submit every document created during the project. So be it your project charter, be it when you talk about your FMEA, the risk management plan, they're talking about X and Y relationship matrix, uh, or for that matter, any SOP document, standard operating procedure, any kind of document that you might have created, that will become a like a repository for the management for future projects. There a lot of time will be saved because they can refer to these documents, and they will be able to use that for future projects. More like this is like to wind up and close the project. But before that, you have to have your control plan in place. You need to stabilize and the process before you submit these documents. And for that, control plan, what becomes like, what is the integral part of a control plan? In control plan, basically, we because earlier we were into an experimentation mode, we were making changes with the process, we're trying some new things to see what's working, whether it's helping us get the result. You were in experimentation phase, but now at this stage you would have improved the process. You have a revised strategy, a perfect strategy, which you know for sure has got the result. Now what do you do for that? You the last revised strategy, or you can say an action plan, uh, this becomes the formal document. These are the things which we must do. You might print them and make it a part of your quality manual, that these are the activities which we must do to ensure that process remains improved. And other than that, your last revised FMEA, which is risk management plan, which also will become a part of the formal document. These were the things we did to secure the action plan, and we must continue doing the same, otherwise my action plans can fail. So last revised activities will be added, and the most important part which comes in here is choice of control charts. Now, which control chart would you be publishing? So which control chart, who will publish it, at what frequency, so various things we need. So, and then what is expected from the person who will publish control charts. Basically, that's something we must mention this in the control plan, that which control chart we'll be working on, who is going to do it, probably a backup person, at what frequency, and if somebody is using control chart, publishing control chart, if the person sees a problem, then what are the next steps he needs to do? What if the person doesn't see a problem? What are the next steps? So bottom line, the expectation management should be done here in terms of control plan, who's going to be doing the control chart part of it. So that's pretty much where you conclude your control phase. So that's the journey that we will be kind of taking it up from regression part till here. So first thing first, it talks about identifying the solutions for the root causes we have validated. The root causes we have understood, like, so we already have some bit of information here with respect to root cause. Say, for example, we compared male versus female. We know that females were doing better job. We compared, say, morning shift versus evening shift. We did that, morning versus evening or night shift. We know, say, females were better. Your morning shift was better. We know what's good and what's bad. Probably I compared, say, the ticket handlers. I have compared the ticket handlers and I used ANOVA for that. I found Vandana was the best. Well, I know who's good and who's bad. So some bit of information I already have. It's just about going ahead and understanding. There's a technique called 5Y analysis. 5Y analysis, or it's also known as YY analysis. That's what we do to get down to the root cause level, the bottom of the root cause. You know the problem, it's been identified, you know what's the problem, but yes, you would really want to figure out what's wrong and why did it happen in the first place. So you would do a 5Y analysis or a YY analysis. But before that, what is recommended is you always should go for a Gamba walk. Now, Gamba walk, anyone knows what is Gamba walk? What is Gamba walk, anyone? Okay, with me. Gamba walk is nothing other than a process flow walk. Wherever your businesses work, like either you are manufacturing a product or you're working on a service line, whatever, wherever the process is happening, which is a problematic process for which you're doing a project, you need to spend time on the flow. You know what's good and what's bad. You've seen, you understand females are good, males are bad. Observe it, see it yourself. Why? And you don't want to hear someone's story about why females are good and why males are bad. You want to see it yourself. You know what's good and bad now, and you know what to watch out for. You know why you're there on the floor. What are you going to check? You already know that. But it's just about seeing it yourself. So Gamba walk is about just observing. You will not go and interfere with anyone. You will not go and start educating people that this is right and this is wrong. No, it's okay to go ahead and ask people as to how do you do your job. What is your understanding level of what doing this job? You can ask that. That's fine. Either you just move around, watch people, take down notes, scribble. That's what you do. It's just about seeing it yourself. You can't start making strategies and sitting in a boardroom and expecting you to go like solve that the grassroots level problem. You want to solve grassroots level problem, you need to get down to the grassroots level to understand it. So yes, you got to spend some time. You know what's problem. Vandana is best, others are bad. Spend some time with Vandana. Watch out Vandana, what she does, Why she's different. Look at others also. Compare. See what's right, what's wrong. What is she doing all this while when she's managing the ticket? Probably others are not well versed with typing. The typing speed of one is exceptionally good, others are not. Probably one is very hardworking, and she's kind of concentrating always on the job. Others are like busy chit chatting, or probably there's somebody's using a cell phone in between. All sorts of stuff. I mean, you'll observe it yourself because you know what's good and what's bad. Spend some time. That's the basic thing. Japanese people put a lot of emphasis. It sounds very commonsensical, illogical probably at times. Probably might say people might find it very logical option or a solution because it's so simple. We always tend to find our peace in when it becomes complicated. But trust, answers to the biggest problems is always found in the simple way. And that's where we will be able to find our solutions. We'll see it ourselves, what's right and what's wrong. Once you have done this, come back and start your brainstorming session with the process experts, subject matter experts, your technical expert. Go and try to, because you already have seen it. You'll be able to make a meaningful conversation with them. Our females are good. Why? Probably male candidates, probably they are too distracted. Every probably 1 hour they need a smoke break, whatever, God knows. But yeah, I don't know, like whatever we would have seen, we would do a 5 analysis. What is this 5 analysis basically? If we said that if you have any kind of problem, you will, if you ask the question why did it happen, you will get an answer. Again, you ask a question why. So basically, it says that if you ask 5 times why, you will get down to the bottom of the real problem. Why did it happen in the first place? Now, it's not necessary that you have to always ask 5 times why to get down to the bottom. Probably in the first why itself, you'll get down to the bottom of the problem. What if it could take more than 5 whys also? But in general, for most of the problems, within 5 whys, you should get your problem. Say, for example, I say morning shift and night shift. When we checked, we know for sure using the test, we found the morning shift was doing a phenomenal job. Night shift was very bad. Well, why? Well, probably morning shift people are more focused and night shift people are not. Why morning shift people are more focused and why night shift ones are not? Well, in the morning shift, there's a management presence. High management people are there in the corporate sector. Pretty much they keep moving on the floor. In the night shift and the graveyard kind of shifts, pretty much no one from higher management would be doing a night shift. They will generally prefer doing a morning one. So people are more casual. Forget about people. They're respecting bosses or also very casual. So people are very reluctant. So I know what's my problem. Lack of presence of high management in the night shift. Well, that's one problem. Well, I have understood, I've seen something this because of the casual attitude, and I've spent some time in morning, I've spent some time in the night shift. I know what's right and what's wrong, and why is that happening. And other than that, well, probably definitely we're working against the shift, against the nature. We're working on the night shift. Yes, so probably a little bit of extra refreshments, lighting conditions, some sort of things needs to be done. Some sort of ice breaking activities to keep people pepped up. Some sort of contests, motivation stuff needs to be done in the night shift. Well, I've seen basis what I see there because I know why I'm there, spending time on the floor, watching out for what things. My objective is clear. I will be able to do this analysis. 5 analysis will help me understand why it had happened in the first place. I keep asking this why till I get down to the real root cause. Well, I'm in my shift, probably people are not motivated. Why? Because probably we have not been able to pay salary on time. People are not motivated. Well, that's what the reason is. You can't expect people to be motivated and charged up because well, even though they are not being paid salary on time, they will be dissatisfied. Yes. So the real reason is not that people don't want to work. No, because the people have not been paid salary on time. They are not motivated. Simple as that. So you got to find the real reason. Say these are not bad people. They are good people. They will be able to perform, but they're not motivated. My motivation is not something which is related to my problem. It's related to your problem because you're not been paying salary. That's how it works. So 5 analysis will help us get down to the real problem. It's a superficial problem that we see. Well, this is not good, that is not right. Bottom line, we need to get down to the bottom, understand why is it happening in the first place. So when you've got a list of possible problems or problems, you will be able to sit down with your process team and formulate a possible solution around that also. So when you talk about possible solution, if I go to this X and Y relationship matrix, just have a look at the template, and that's what we use. in a Six Sigma world, say we have got two examples here. Say trainer, we had trainers A, B, C, D, E. We had like five different trainers. A was absolutely great. I mean, this guy, anyone whom this person trained, was doing a phenomenal job. And other trainers, B, C, D, E, they were not good. They were not performing well. So pretty much that became as a root cause. Shift wise, we found that morning was good and night was bad. So we have these two root causes identified from the previous phase. We sit down as a team, we sit down and like list down all possible action plans which can be done. So we talk about train the trainer program to be introduced. Well, everyone gets trained, even the trainers, they are put into a training program, so they will keep getting updated, refreshed in terms of their knowledge, everything. So that'll help us bridge the gap between their understanding level. Best practice sharing to be done by trainer A. Well, my trainer A is the best person, role model for everyone. Why not this guy tell everyone the trade secrets, how he manages to do his job, and while others can also learn from him. Uh, Bridging the knowledge gap between trainers about process, policies, and everything, that will help us kind of narrow down the gap and bring everyone on the common level. Introducing performance link bonus with people trained by them. So I will rather introduce a training incentive plan where I will reward those trainers. If somebody whom you have trained does phenomenal job, you get money. If they do well, you make money. If they don't do well, you don't make money. So that ways people will be more like motivated to ensure that the people trained by them perform well. I'll have my skin in the game. I'll have my vested interest to make sure that you do well, because otherwise I will not make money. You can take some feedbacks from the trainers, anonymous feedback, so that you get to know what's the real problem. You take the real feedback. So bottom line, you can sit down and with the team and generate a long list of possible action plans. Similarly, you for the shift related, we had some action plans listed here. So we'll go and do a brainstorm. So this in real project, you could have got 30, 40 different action plans. You cannot implement all the action plans at one go. So pretty much you need to have some sort of priority decided for that. What you do is here, you get your action plans weighted on a scale of 1 to 10. Now, who decides the weightage on a scale of 1 to 10? Your process owner, the subject owner, the champion, the key stakeholders of the management. They will be able to understand like whether this is more critical, this is less critical. Dip on a scale of 1 to 10, what kind of rating would they give? As a team, higher management people, they will kind of finally decide what should be the weightage given to every root cause. And then we start with this basically basic discussion, which will include in this discussion when we're giving rating, we will have all the process owners, probably some people from quality, some people from training, all the relevant people with respect to this business will be invited and to participate in this activity. People will come with different opinion, which is good because at this stage we really want to fix the business and we are trying to come up with action plans. Now, good practice is to get the rating done on scale of 0, 1, 3, and 9. If there is no impact of action plan on the root cause, you will give it a 0. If there's a low impact 1, it's a medium impact 3, and a high impact will get us 9. So we discussed about train the trainer program. If we introduce this, that will significantly improve the trainers. Yes, it'll help us bridge the gap. So we talk about train the trainer program will have a high weightage. Yes, we talk about high weightage, which is 9. Uh, we try to always and also understand if we implement this action plan, will it also improve my other root cause? If it improves my other root cause, I'll say probably not direct impact, but yes, some bit of medium impact is there. So I'll say given a rating of 3 in this case. So as a team, we sit down, brainstorm, and give certain ratings. So for this one, we got like both rating as 9 and 9. So although this action plan was made for trainer, which was supposed to have a good weightage, we also found that if this trainer A does the best practice sharing, it will also improve the shifts also, other shifts also which are not doing good. The night shift people will also benefit from this. So yes, we will see and we can get the rating done. In the end, the two scores that we end up generating, one says completeness matrix, which is let me quickly show you. Pretty much this is the last topic we have for today, and then rest of it we'll be covering up tomorrow any which ways. But now just have a look at what the scoring is done. We will add up all the ratings of the action plans, and we multiply with the weightage that was given by the process owners or subject matter experts. That's how we get the weightage. But honestly, this rating will be of no help to us, no use to us. Why? Because we have already moved one stage ahead of root causes. We had root causes. This is giving us the weightage of root cause given the action plan. We are not looking at root causes anymore. We already know root causes. We have created action plan out of root causes. So we are concerned with deployment metrics, what we will be implementing. This is what we want: the action plan, the impact of every action plan, how much critical is an action plan. So we get these ratings done. Now, how are these values calculated? Let's quickly have a look at it. Say, open up the bracket, this multiplied by the weightage plus this multiplied by the weightage. That's how we get it. So let me show you one more. Again, we have a place. Let me give the, for this one, this multiplied by the weightage plus this multiplied by this weightage. So you get this scoring. Ultimately, we need to get the scoring because deployment matrix is what we say. We will be deploying it. We will be implementing it. This is the deployment part. So higher the weightage, more important is that root cause, because that is what that was created for one action plan, but it's impacting two different or multiple root causes at the same time. So we'll go in the descending order of the weightage we get here, and we will implement it. It's very important for you and for your management to see early results. These action plans will have a lot of possible like positive impact because the high weightage, they are impacting high on every root cause, which is a good sign. So you will always go with the priority order, the highest weightage in the decreasing order of the priority, which will help you keep that action plan, like get the early success. These are kind of like low hanging fruits in your project, which will get you early success. Your management is anxiously waiting for results. You are also waiting for results. Your team is also looking up to you. So it's very important to see early success, and that's what it helps you prioritize and plan, because you may be having 40 different action plans. You can't implement 40 action plans at one go. So the right order will be given by this. Is it clear to everyone? Is it okay? Any questions on X and Y relationship matrix? Is it okay with you? I would request you to please confirm. Is it okay with you? Uh, are you there, Avni or Shreya? Because other people have just dropped off. I just realized that.
Yes, sir. Yes,
Yeah.
sir.
Okay, it's okay with you, all right? So pretty much that's the last topic we had to kind of cover up, because the rest of it we will be covering up tomorrow. Pretty much from FME onwards, we'll be till control. We'll be covering up tomorrow, the control charts and everything. So that's the agenda. But yes, still now, whatever we covered till X and Y relationship matrix, is there any question that you probably want to kind of clarify, or else we can call it a day from pretty much that's all we want to cover up today. Any questions on the part that we covered up today?
No, sir. It's clear.
Okay, all right then. So, all right, so we can call it a day, and let's catch up tomorrow for the final session.
Okay, sir.
Okay,
Okay.
thank
Thank you.
you. Thanks. Bye bye.